Today we're going to talk about explicit formulas for sequences. Okay? And our goal here, our objective, is to write and use explicit formulas for sequences. Say, well, we already have a way of writing formulas for sequences. That we do. We have recursive formulas. And as you recall, if we take a sequence such as 2, 7, 12, and 17, okay, we can write a recursive formula. Okay. Write a recursive formula. And certainly we look at the pattern, we say, okay, u sub 1 is 2. And our pattern is that we are adding 5 each time. That's our pattern. So u sub n equals u sub n minus 1 plus 5. And from there, I could ask you to find u sub 5 and u sub 6. But how about u sub 74 as well? Okay. So if I want to find u sub 5, well, this is u sub 1. U sub 2 is 7, U sub 3 is 12, and U sub 4 is 17. So if I'm looking to find U sub 5, well, that's pretty easy because U sub 5 would come right after U sub 4, and I would just have to take 17 plus 5, which would give me 22. And then to find U sub 6, I would add 5 to U sub 5, which would give me 27. So U sub 5 is 22 and U sub 6 is 27. We've done that before many times. Now U sub 74 would take a little bit more work. It would take a little bit more work. I would have to, the problem with the recursive sequence here is in order to find U sub 74, I need to know U sub 73. Because if I know U sub 73, I could then add 5 to it. But I don't know U sub 73. So in order to find U sub 73, I need to find U sub 72 and then add 5 to it. But I don't know U sub 72. And then in order to know U sub 72, okay, U sub 74, we know it equals U sub 73 plus 5, but we don't know that. U sub 73 equals U sub 72 plus 5, but that doesn't help us, okay, because we don't know U sub 72. So that's be very difficult for us to get to U sub 74. It would at least be time consuming. We could do it, but it would be very time consuming to use a recursive formula to get to U sub 74. An explicit formula is going to make this a lot easier for us. Okay, so let's think about what we would have to do with recursion to get to from U sub 1, which we know is 2, right? We know U sub 1 is 2, and then we wanted to get all the way to U sub 74. Well, we know what the pattern is. We have to add 5, and then we'd have to add 5 again, and then we'd have to add 5. We have to keep adding 5, adding 5, adding 5 until we get all the way to U sub 74. Well, that would involve adding 5 73 times. Because if I'm at U sub 1, I have 73 steps of adding 5 before I get to U sub 74. Well, I mean, it could be done. Like I said, it'd just be time consuming. But what if I ask you for U260? You're going to do that one too? Okay, so an explicit formula is going to give us a way to go right from U sub 1 all the way to U sub 74 in one step. And it's right here is our little shortcut, because if I am adding 5, okay, if I'm adding 5 73 times, I can write that in a slightly different way. I'm adding 5 73 times. So it's 5 times 73. Now that I can do at once. I can take 5 times 73 and add on. So we go 2 plus 5 times 73. It's 367. Well, there is U sub 74 is 367. Not something we want to get going the long way. So we're going to look at an explicit formula that comes right from this idea of repeated addition or subtraction becomes multiplication. So it looks like this. An explicit formula for an arithmetic sequence. Okay? And it's only one thing. We no longer need to know u sub 1. U sub 1 is actually included in our formula. So it's u sub n equals u sub 1. There's the u sub 1 in our formula. Plus d, that common difference, times n minus 1. That's going to be our explicit formula. Now let's look back for a second and see if that fits what we did back here. Okay? U sub 5 or U sub 74. U sub 74, we said it took 73 times. Well, 74 minus 1 is 73. Our common difference was 5. 7 minus 2 is 5. 12 minus 7 is 5. 17 minus 12 is 5. And so it fits exactly what we did here. In fact, for this particular one, if we want to go back and write our explicit formula, for this sequence that we have, it would be u sub n equals 2 plus 5 times n minus 1. Now I could ask you to find u sub 100, u sub 67, u sub 750, and it wouldn't take any longer to do any of those than it would to do u sub 74. Okay? So let's look at an example. Maybe we start at, here's our sequence. Okay, we want to write an explicit formula and find, I'm going to write an explicit formula and find u sub 100. So 12, 3, negative 6, negative 9. First, we're looking at the pattern. What's happening? Well, 12 minus 9 is 3. 3 minus 9 is negative 6. Negative 6 minus 9. Looks like we're going down by 9s. So our D is negative 9 here. And our u sub 1 is 12. So my formula is u sub n equals 12 plus negative 9 times n minus 1. Now to determine my formula, u sub 100, it would equal 12 plus negative 9 times 100 minus 1, which is 99, of course. So I'm going to do the math here. So it would be 12 plus negative 9 times 99 is negative 879. That would be negative 879 would be our u sub 100. All right. Now that's arithmetic sequences. Of course, this one was repeated subtraction instead of repeated addition. But let's look at geometric sequences. Okay. So say we have this. Now, of course, we could write a recursive formula. Which we know u sub 1 is 4, and u sub n equals u sub n minus 1 times 2. But again, we're going to run into the same problem. We could easily find, since we have u sub 1, u sub 2, u sub 3, and u sub 4, if we wanted to find u sub 5, we could easily do it by multiplying 32 times 2. If we wanted to find u sub 6, we could find those pretty easily. U sub 5 we know would be 32 times 2, which is 64. And u sub 6 would then be the 64 times 2, which is 128. But again, what if we want u sub 74? Okay. Well, if we think about, just like we did with the last one, if we go from u sub 1 all the way to u sub 74, u sub 1 we know to be 1. We want to figure out what u sub 4 is. U sub 74 is. Well, we know that our pattern, we can look at our pattern. We know that it's times 2. We've already discussed that we're multiplying by 2. So I'd have to multiply by 2 and multiply by 2 and multiply by 2 and keep multiplying by 2 And again, I would do it 73 times. 73 times. Okay. Well, last time we found a shortcut for adding 73 times. Is there a shortcut for multiplying 73 times? Sure. It would be 4 times 2 to the 73rd power. We make it an exponent. Okay. And you're going to get, and let's put that into our calculator. So this would give us u sub 74, which I'm going to put into my calculator and show you what it looks like, because I want to show you something with the calculator here. 2 to the 73rd power. And that, you're looking to say 3 point, what? That's a really small number. No, it's actually a really big number. You have to look at the whole thing here. Look at the end, it says E22. That is scientific notation. What that means is you take this decimal, and since this is a positive 22, we would move the decimal to the right. If it was negative, we'd move it to the left. But we're going to move it to the right 22 times. So I'm going to take this decimal and move it 1, 2, 3, 4, 5, 6, 7, 8, 9. Would put it behind the 6. And then I would put 13 zeros after it. It's a really, really big number. It's all of this with 13 zeros after it. But I'm not going to ask you to write it that way. Just write it this way. 3.777. Always do 3 decimal places, as we talked about. So you could also use 3.778 here. Right? We either truncate or round to the 3rd decimal place, and then put E22. And that would be an acceptable answer. Right? So the explicit formula for geometric, and again, that was 3.777 e to the 22 sequences. Explicit formula for geometric sequences. It's u sub n equals u sub 1 times r, that common ratio. In this case, it was 2, right? To the n minus 1 power. There's that n minus 1 again. That is our explicit formula. Okay. Now, this was growth. Let's look at one that is decay. Okay, so here's an example. Okay, so say we start at 300, 75, 18.75, 4.6875, and that's our sequence. Okay. Well, we want to write an explicit formula. And find u sub 100. Well, we take the first 2 terms, 75 divided by 300. And that gives us 0.25, 1/4. That's R. If we want to check, we can take 18.75, the third one, and divide it by the second one, divided by 75, and that also equals 0.25. So that's just to double check what we have R correct. So we know what u sub 1 is 300, so our formula is u sub n equals 300 times 0.25 to the n minus 1 power. And then to determine u sub 100, I simply plug 100 in, okay, and we put that in our calculator, and you're going to find a strange result again. I'm going to find a strange result again. And it would be, so we put 300 times 0.25 to the 99th power. And we get, again, that e on the end, e to the negative 58, which means this time we would take this decimal and move it this way. So we put it in front of the 7, and then we would keep moving that decimal and put zeros in, and we'd have 57 zeros in front of that 7. Well, that's too many digits to write. So again, we're going to write it in the scientific notation as it's given, 3 decimal places, so 7.467, or you could do 7.468, either would be acceptable, and then e to the negative 58th power. That's how that would work.